Welcome to my channel AI Basics with AK. Here we are with another new episode on functions. Why waste time? Let's directly jump into our episode. Episode 11 Functions. In this episode, we will learn how we can define a function and how we can call function using a function, like how we can call a function inside a function itself, and how to write multiple functions inside a function, and how to create a generator function where popularly it is used to generate some sequential data like 1 to 100 or 1 to 1000, any number of kind of a thing. Beautiful, right? So let's jump into how to we define a function. So as mentioned here, we define a function with a keyword def, and this is my function name. Okay, so with a definition, we are creating a definition that this is my first function, my underscore first function, with a parenthesis. Here inside that parenthesis there is nothing, so it is an, we are not passing any arguments. Here we will say that this function does not have any arguments. So inside the function there is only a one line statement here which we are calling as a print, which is my first function. Once you just write this statement, nothing will get executed. To execute it, we have to call our function name, which is nothing but my function, my underscore first function. When you call this function, this function, whatever the content inside this function gets executed. What is the content inside that function? It is printing a statement, my first function, which is how it gets executed. Beautiful, right? Now here in the second function, if you can see here, the line contains, where we have used an f style printing operator, the number called in the function, I'm calling it as a number. Now while calling that function, we are calling it separately by passing different arguments. Here we are calling it my underscore second function with 1 as my argument. Here my underscore second function, we are passing 10 as an argument. While calling them separately, just by passing these numbers, we are getting a different outputs. So that's the beauty of a function, where you can write a generic content for different input parameters, such that your code becomes a little bit easier to read, and you can reuse that function for multiple inputs, which is the prime purpose of creating a function. Now, since you understood the prime purpose, what is the basic rule of creating a function? You can create function by using the same variables that we have learned in our second episode, which is what we can, either it has to start with a letter or underscore to define that function. Okay. Now let's go to our third function. Now so far in first function we did not pass any arguments. In the second function we only passed one argument, which is num. However, in third function we are passing multiple arguments, which is num1 and num2. Here still we have used, just for reference sake, we have used the f style printing operator, where we are calling these numbers and also creating a total of it. So when we are calling this third function, my underscore third function, here you can see that we are passing two different numbers, 1, 10, and then you can see that the numbers called in the function is 1 and 10, and that total is 11. So accordingly, by passing different input numbers, here when you pass 1 and 10, the addition has become 11. When you pass 30 and 70, automatically the addition has become 100, along with different printing parameters. So what we have learned is that the functions, we can write some generic arithmetic operations as well. Beautiful, right? So let's jump into that arithmetic operations. Now you can see here that we have defined a function sum underscore of underscore number by using the same variables as an arguments here, which is num1 and num2, and then we have defined a variable total by adding these numbers. Now I'm calling this function in the same way we have called it in the previous, which is my underscore third function here. Earlier the output has come because it has printed this variable. However, when we are calling this number, a variable total is getting created, but however we are not using it for display or returning it. So that's why no output is seen here. You can see that there is no output while printing this statement. So to return a value from a function, we have to use a keyword called return. Now here we are calling it as defining the same function. We have summed up both num1 and num2 into a total variable, and then we are returning that total variable here. So the moment you call this function, right now 100 has been written. Instead of actually creating a variable, we can also directly use a return statement by adding num1 and num2 without creating a total variable. Even this is more easier because we don't need to create any intermediate variables, so which becomes the code becomes a little bit more hygienic if it is a shorter functions. Of course, for shorter functions, we can use lambda functions, which we will learn in our next episode. So when we are calling the same function, we can see that 100 as an output, that we can see that these even in f-style printing operator we have got the same 100 output, and also using this return statements also we are getting the same 100 output. So we can expand this learning to any different types of arithmetic operations. As an example, you can see an function here where we have defined an area of a circle as pi r square, and then when we have passed a radius of the area of a circle as 3, it has given its area as 28.26 in its units. Beautiful, right? So defining a function, we have to use a keyword definition. We can create functions either with one argument, two arguments, or no arguments. Either we can use a print statement such that we can see what is happening inside a function, or else if you want to extract some content from a function, you have to use a return such that you can get the output what is happening in that function. And you can also store this sum of underscore, so you can assign this also output into a variable which we can use for further downstream operations, which also we will learn all those, we will implement all those things in our next episodes. So in this slide, we will see how we can call a function inside a function. To explain this usability, we are discussing two examples. One is adding sum of n numbers, that is n into n minus 1 by 2. We can use directly that formula, but however we are using to demonstrate that example. And similarly a factorial example, like 1 factorial, 2 factorial, 3 factorial, etc. Like we just pass a number and how we can calculate that output. And in the first part, we are discussing a longer version of it in both these examples. And in the second part, we are calling the same function of the original function, and then we are seeing the beauty of this calling a function inside a function. Now in the example here, while adding the sum of n numbers here, we are defining a function here, and then we are initiating a variable and then assigning that variable with 0. And then we are adding by creating a range. You know that range, right? Range is nothing but when we call that range of n, it creates that list of values like 0, 1, 2, 3 and 4. Why we added n plus 1? Such that it doesn't end with that 4. We have to also create, when we call range of 3, ideally the list will be created as 0, 1 and 2. So to add n numbers, we have to ensure that we are calling the third also. So that's why we are incrementing that range value here. So when we are using for I in range 1, so we are using an iterator and then adding each of these numbers here. And then finally, we are, after completing that iteration, this total will add all these all these numbers inside this iteration, that is the range of this list, and then that gets stored in total variable and we will return the total variable. Similarly, the factorial function here on the right hand side, we are initiating a total, we are creating a variable total and then we are assigning a value 1. Same here also, we are using an iterator function where we are increasing it by one variable and then we are multiplying each and every, because 3 factorial is nothing but 3 into 2 into 1. So we have to multiply those numbers individually. And then after completing that iterator function, the total will contain this final value and then we are returning the total variable. So when we are calling this number sum of n numbers 4 and sum factorial 5, we are actually calling those functions and we are getting that respective output, which is nothing but 10 and 120. Excuse me for that line, I think that's some mistake while I'm using it. And while coming to the calling a function inside a function, what we are trying to do here is that when n is equal to 0, because we return the value as 0 here, which I'll explain it in a minute. Else we are saying that you just add the numbers, sum of n numbers n minus 1. What happens here is that, say for example, when we are passing a 4 will come here. So since 4 is not equal to 0, it passes into the else loop. Now 4, and then we are saying this is 4, it returns the value of 4, and then we are calling this function sum of n numbers n minus 1, which is nothing but 3. So this is passing again into this function and comes here and then adds it up here again. Got it? And then we are passing the 2 variable, it passes into this loop and comes here too, and then it goes into here and 1 will come here. Again, when it becomes 0, we have to stop it, right? Because we cannot pass on continuously, kind of a thing. So when it becomes 0, we are saying finally, absolutely we are saying return 0. This becomes, it finally returns 0. And then finally everything gets adds up automatically, because we are calling this function inside a function and then this value gets returned automatically as a sum, 10. Beautiful, right? Here also in the factorial the same thing happens. 5 gets multiplied by 4 on a decreasing note, and then 3 on a decreasing note, and 2 on a decreasing note, and 1. So finally when we multiply all these things, then output of 120 we will get it. Beautiful, right? So this is the beauty of calling a function inside a function, and then that's how it is very helpful for us to write some optimized functions rather than also writing an iterator functions. So that's how it is. Now let's explore an inner function. In an inner function, we define a function inside a function. So here we are defining a function multiply, inside which we are defining a function sum of numbers. Okay. So here I have discussed 2 examples here where I'm passing here I'm arguments are number 1 and number 2, However, in the second function, while passing in arguments, I am also defaultly, these are a default assigning of those variables. Say for example, even though if I don't pass the arguments, what I'm saying is that, okay, if none of the arguments are passed for number 1 and number 2, you can directly take the values as 2 and 3 directly and perform the operations. If we don't, if we do the same things in this here, it will throw an error because it is expecting some of the arguments to be passed into that function. So that's how it we can also explore it out. Say for example, if we are writing a complicated functions, and then we can assign some default values, like under default scenario how this function has to work. And if a people just write this function also, they automatically the default execution of that function gets executed with some default parameters. And if people want to hyper tune those functions or tune that methods, we can actually pass on that variables, or people can use that multiple values to that variables to optimize that output as per their requirement. Okay, now so that's a functionality of actually passing in arguments. Let's return into the functionality of an inner function here to just demonstrate it. Now here we are defining a functional multiply inside, and then we are passing a variables number 1 and number 2, and then inside that what I'm trying to do is define a function sum of numbers with a variable number 3. And then here inside this function we are just adding this number, the same number, 2 times. And outside this function we are calling this inside function here, wherein we are passing a number 2 into this and then multiplying with number 1. So ultimately what we are expecting is that this output should add number 2 times and multiply this entire output with respect to number 1. So when I'm passing a variables 2, 3, so what it has to do is that it has to add 3 plus 3, which is 6, and into multiply by 2, the output should be given as 12. So in this way we can also write some functions and then call those functions inside those functions as well with a different function name. This is especially becomes so helpful when we are actually creating some of the advanced models, custom models if we want to create it, or custom programs or that is required for our data science activities. The same thing right now, the same example here, we are as said above, we are just passing some of the default assigning, we are assigning the default values to these arguments as 2 and 3. And then even though we did not pass any arguments here, we can see that the output we have got it as 12. When we are passing this, just print multiply 10. So this 10, it takes as the first argument of number 1. So that's why you can see that 60, and you got the same 60 and 60. And then when we are passing multiply 20, 30 here, or number 1 is equal to 20 and number 2 is equal to 30, then you can see the same output here. Say for example, you want to alter only one of the number but not number 1. You cannot just specify that okay, number 2 has to be 30, because when you specify multiply 30, by default it will take as number 1 because it's in a sequence. So to actually change only for number 2, you have to explicitly mention while calling that function as multiply number 2 is equal to 30. So you will get a different outputs for both of them. So as I'm told just at the beginning of this slide, like changing these input values, we can get a different values here apart from the default expectation, which is nothing but 12. Beautiful, right? Now we are with the last slide of our episode for today, which is nothing but our generator function. In a generator function, what we in generally wants to create is that we want to generate a sequence like 1 2 3, or else 1 2 3 4 5 6 7 8 9. Like we want to create some generate those incremental numbers automatically instead of calling it explicitly. How do you use it? How do you say that, okay, right now it is 1, okay, you have to return the next value 2? How do you say a function returns separate values when I'm calling you separately? Instead of using a return statement, you use a different function, different state, different name, which is syntax name, which is we call it as an yield here. Instead of a return, we use an yield here. So that's why here what we are trying to, we are just calling a function here. Say for example, n is equal to 1 here, basic statement here. This is one of the basic generators function we are saying here. We are defining n is equal to 1, and then I am saying yield n, and then I am incrementing that number, and n is equal to n plus 1, which means I am incrementing that number to 2, and then I am returning that value as 2. Similarly, I am incrementing the value to 3 and then returning that value 3. So this generator function can generate up to 3 values, which you can see it here. How do you call that generator function? By using next statement. You assign that value to a g, and then you call it next g, next g, next g. Accordingly, you will get an output 1, 2 and 3. After this, say for example, still you got an xg is equal to z, it says that my iteration has stopped completed. There are no further next iterations to it. Now say for example, if you want to create a generic kind of a thing, you have to give a starting number. You have to give a starting number, you have to give a last number. When n, we are saying n is a start, similar way here. And then when n is less than last, which is nothing but last, while it is last, you have to yield n, and then you have to increment n. So it generates this entire range, whatever we give it as an starting as a last starting number and a last number. So when we pass these variables as 1, 3, since we have specified n less than last, so it generates only 2 iterations, which is 1 and 2. When we are passing as 1, 10, since it is less 10 has 9 is less than 10, we will get 1 to 9 here. So this entire slide functionality is to explain, apart from return just returns only an absolute number. You can also yield multiple values in a sequential manner as per our requirement by using an yield function. And also, how do you call that? Using a next statement, and then iteratively calling it till that loop gets completed. Beautiful, right? So that's it for today's episode. And as usual, if you want to practice all these things that we have discussed here, you can just click on this link where you can see in a Colab link, and then you can follow all these examples that we have discussed in this episode, and then you can just practice it. Before jumping into our demo session, as usual, let's see the homework for this episode. So the homework is very straightforward for this week. What you have to do is that you have to create a function called calculate_discount_price, which takes 2 parameters, price and discount rate, right? So given a price and a discount rate, you have to calculate the discount price, which is straightforward multiplication, but you can just create a function and then write some beautiful print statements as well inside it. Also, in question 2, I'm requesting to create here a generate operations function which takes two parameters a and b, and inside generate operator functions you have to create another function called perform operations which takes the same parameters a and b but performs three operations, which is addition, subtraction and multiplication. And finally, generate operations should return the result obtained from the perform operation functions. It means it has to return three values: addition, subtraction and multiplication. Although in the entire episode we have discussed only returning only one value, we can return multiple values by giving a comma to it, which we will see it in our demo session. Okay, that's it. Let's jump into our demo. See you there. Same content that we have learned in our slides, and with few extra variables that will pass it as inheritance statement, which is useful for your homework. Now, how do you define a function? Use a diff as our keyword, and let's start with one simple first function. Say my first function. Here there is no arguments, and inside this we will create a first statement called print this is my first function. How do we call this function? By simply my first function with the braces. So on the right hand side you can see that automatically output got printed, which is okay, which prints as this is my first function. Let's modify this first function with a numerical value num1. The moment you write num1, this first function says that it requires a missing argument because we did not pass any argument in our calling function. So that's why it has thrown an error where it says that this is a type error. It is expecting some position. You have to give some position of that. So either you can pass it, say num1 is equal to 10, which is a valid thing, or else simply you can also pass it as 10 as simple number. In either cases, automatically this print statements get executed. Say for example, you want to exactly print what is getting captured into that variable, you can use an f-style argument with your number1 as a variable. Automatically you can see that our print statement gets modified as this is my first function with a value of 10, which we are passing it here. Beautiful, right? Now let's define the functions with a return variable. Now say defining, this is my, say for example, addition of numbers. Add numbers, say num1 comma num2. Okay, so num1 comma num2, and let's return these numbers by using num1 plus num2, and let's call this function say add. We have to specify it, that's why it is again throwing an error on the right hand side if you can see it here. So we have to pass that value, say 5 comma 10, but however we did not see any output here because we are not storing this output anywhere else, right? Either you can print it in case it prints a 15 variable. Also, instead of printing, we can also create a variable, so x is equal to add 5 comma 10. Automatically a variable gets created x by adding these numbers 5 comma 10 here. Beautiful, right? So if we have seen in this particular episode, we are trying to add some nuances of what we have learned in our slides. In future episodes also we will be using this manner where we will learn some of the basic fundamentals in our slides, and then we will try to build the content of what we will learn from the slides in our demo episodes. Okay, Now let's increase more arguments. Say for example, def add number 1, number 2, number 3. Now say for example, we want to return two things. So add and multiply. Let's say it is add and multiply. Now add 1. Say for example, we will say it is num1 plus num2 plus num3. And mul1 is nothing but num1 into num2 into num3. Here inside this function add underscore mul, we are performing two operations, which is addition, wherein we are assigning a variable add1, and multiplication, which is multiplying three numbers, which is number 1 into number 2 into number 3. And finally, say for example, earlier we used to return only one variable, and let's see what it does returns. Add mul, say for example, we are passing three variables, say 1, 2 and 3, and then say for example, let's assign a variable to this y. Add underscore mul, sorry, not num, that's why I see an error at the top. Now you can see that it adds the numbers 1, 2 and 3, and it creates a variable 6. Although the multiple operation is performed, since we are not returning it, we don't get an output here. Say for example, let's pass both the variables add 1 comma mul1. Now it says it's a tuple, so it's generating it as a tuple. So to extract tuples, let's output as add 1 comma mul1. Now automatically, if you can see it here, sorry, mul1. Now since 1 into 2 into 3, which is 6, and 1 plus 2 plus 3 as 6, you are not able to identify whether it is which one is which one. So let's change this 1 to 10. Now you can see it very clearly. 10 plus 2 plus 3, which is an addition, which is my first return value add 1, gets stored into this tuple, which is add 1 here. And similarly, 10 into 2 into 3, which is 60, which is getting multiplied in mult1 and passing as a second tuple list, it returns into my second list here. So accordingly, automatically two variables are getting created, add 1 and mul1, and gets assigned those values here automatically. So in this way, you can return multiple statements and then assign them by using a comma here. Beautiful, right? Now let's do the same things by using an inner function here. Okay, now first initial declaration, say num1 is equal to, let's define it with some default numbers. Num2 is equal to 3 and num3 is equal to 4. And inside this function, we'll do perform operations, where we will pass on the specific numbers, which is num1, num2 and num3, and perform these operations. So now let's perform addition operation. Num1, num2, num2 and num3. Here let's call it is a multiplication operation. Now for returning a statement, instead of returning add 1 and mul1, here we will call the specific functions here, num1, num2, num3, comma this. I'm just copy pasting this center. I am returning this both way. Now instead of initial declaration, let's say we will say the same function with an add mul underscore 2. So let's define a number here, 10 comma. So let's not define anything here, and then let's assign a variable here. You can see, oh, why do you see a null here? What is the mistake that we have done here? We have created these functions and then we have defined these two inner functions. What is missing here? Because since we are calling these functions, a variable is getting created, but there is no return statement here, right? So instead of adding here, let's directly use a return statement here. Now we should see at two different values automatically, which is 9 and 24. Automatically, by separating a comma, we can assign them as two different variables that we have seen also earlier here. Beautiful, right? So here we have seen the beauty of calling in functions inside a function, but it is called as an inner functions. For this demo episode, I am not going through the calling function inside a function. Beautiful, right? Now let's create one more example, which is, say for example, let's create one more function, say factorial, in a long way, factorial of num. Now we are passing factorial as a 1. For that, first we have to initialize some value which is a 1 as my first value, because we have to multiply everything with respect to 1, which is my first number, right? 1 into 3 factorial, which is nothing but 1 into 2 into 3. And then we have to run an iterator, right? Iterator for I in range num. Say for example, let's use range. Let's see why we have to add it as 1. Now let me print range of 3. Okay, let me just first do the total is equal to total plus I. Here the range is 0 to 3, okay, and then let's convert, say for example, this into a list. Okay, so when we mention range of 3, actually we get the values of 0, 1 and 2. Okay, so that's why we have to add 3 plus 1 to actually get our values until 3. So 0, 1, 2, 3. If you want to get this entire list, we have to add 1 to this. So that's why we are adding range of num plus 1. So we are adding here. So factorial, it's not an addition, it is a multiplication. So after this multiplication of this, running this iterator, we will get that entire value into this total, and then finally we can return the total as a factorial. So to call that factorial, let's say for example, say z is equal to factorial of 5. what is the mistake here? The mistake, what is the mistake of this function here? The output, okay, it throws z is equal to 0. Why? Because here we are adding, multiplying even with 0. So the moment anything that gets multiplied with 0, the total becomes 0. So to avoid this, what we can do, we can give a specific range. One thing you can do is that you can mention the range as 1 comma 3. Now what happens is that your range becomes 1, 2 and 3. Automatically your output will become 128. There are other ways also we can do it, where we can use an if operator entire this instead of where you can say that, okay, if the value of I is equal to 0, okay, just don't multiply it, kind of a thing. But however, this is a safe side because we are actually defining that list between these numbers, which is 1, 2 and 3. Beautiful, right? Now we can do several things like returning multiple variables as per our defined functions, and then maybe if we want to define, say, perform all operations under one umbrella, we can define addition, multiplication operator, factorial operations, etc., etc., write so many things, and then return everything under one return statement by specifying a comma. And then we can define uh, some default numbers. Say for example, here we have defined some default numbers, sorry, and say for example, even if I don't give the default numbers also, say v1, I'm not defining any default numbers here because there are already default numbers 2, 3 and 4 right here. That the same numbers should come out here, 9 and 24, which we already have seen it out here in the v variable, where we are passing it explicitly as 2, 3 and 4. We get the same output here because we are assigning those arguments of number 1, number 2 and number 3 with values automatically as 2, 3 and 4. Now we will see a final example for our demo session of generator. I'll discuss a basic generator, how to define the basic generator. Say we can, the function definition remains the same, where we can call it as a generator. Okay, this is my generator is a function name, and then here when n is equal to 1, we will say yield n, and n is equal to n plus 1, we will yield again n. That's it. Now what happens if we just declare this and leave it? And then let's call my underscore generator function and then assign a value z to this. So automatically he can here see that it's a built-in generator, a generator function or created here. So that's why you can actually print here next g. So you can see here 1 got created, even 2 got created. Now it has to throw an error. So it has thrown an error as we expected, saying that it has iteration has been stopped. There is nothing in that iteration. So that's why it has thrown an error. So as we have seen it in our slides, we can create a more generic kind of a thing of the same generator function using say generator generic, say first comma last, and is equal to first, where which it has to yield it n, and while n is less than or equal to last, I will yield n every time, and then I will increment n to n with 1 always. Now let's, sorry, what we'll do is that we will create another generator function here, g1. Again one more generator function here, but however, ideally when we print here, next g1, nothing is there because we have not passed any arguments here. So what we have to do is that we have to pass an argument, say for example 1 comma 10. Sorry, my generic generator, right? Sorry, generic generator. Now so automatically the 1 got printed here. We can also assign a variable to this. Next, say g. So b2, b2. So next g1, right? That's why it is throwing an error. It is g1. Next g2. So g2 is not. Next g1. So automatically these variables are getting incremented with value 1. That's the beauty. Similarly, we can create those incremental values with more numbers in this manner. So in this demo episode, we have seen the first simple functions as well as addition by returning one variable, multiple variables returning, and then inner functions inside the function and returning those functions multiple times. Factorial function, just for an explanation why we have to define that range as num plus 1. And then finally a generator function, a simple generator function, as well as a generator generic function. Okay, that's it for today's episode. I hope you loved this content, and in future episodes I'll improve my content as well. If you like it, please do like it, and then please do subscribe for my channel for more and better enhanced content that will further motivate you. Thanks a lot. Have a nice day.